Right, this video is on density, what density is, and how to calculate density using the density formula. This should be a review, and you should have seen density lectures in your previous science classes, so we will jump right in. Okay, so what is density? Basically, it's a ratio of an object's mass to its volume. Okay, so ratio should make you think of a fraction. So if it's a ratio of mass to volume, then density is equal to mass divided by volume. Or D for density equals M for mass divided by V for volume. And of course, we are more used to seeing it written like that than in word form. So this is our density formula. So if I know the mass of an object and the volume of an object, we can calculate density. Okay, so let's talk about the units for density, because this is a little bit different and sometimes causes some confusion. Okay, so let's talk about if we have what I'm going to refer to as a regular object, like a cube. Okay, and I'm interested in determining the density of this cube. Okay, so density is equal to mass divided by volume. All right, so I could take that cube, and to determine its mass, I would put it on a balance, and a balance is most likely going to give me a unit of grams. Okay, so I'm not doing any numbers here, I'm just looking at units. So if I put that cube on a balance and my unit was grams, then my mass unit would be in grams. Okay, and then the discussion becomes, well, how would I find the volume of that cube? So most of us know that I could find, the volume of that cube by taking its length and its width and its height and multiplying those three together, right? Volume equals length times width times height. So normally we're working with things that are rather small, and we're measuring the length and the width and the height in centimeters. So my volume would be centimeters times centimeters times centimeters, which would give me some number and a unit of centimeters cubed. Okay, so for my volume, in this case, I would have a unit of centimeters cubed, or cubic centimeters. So this is my first unit for density, grams per cubic centimeter, or grams per centimeter cubed. Okay, so that's one unit of density that you may encounter as we're working through problems, but there's another one that you might see, and this is more commonly for what we're going to refer to as irregular objects. So maybe a rock. I don't know how to draw a rock. Okay, so if I wanted to determine the density of this rock, I would need its mass and its volume. Again, for mass, I could put it on a scale and it would give me a reading in grams, so G. But for volume, I can no longer do length times width times height. This isn't a cylinder, so I can't use the cylinder formula. So I run into a little bit of a problem. So how do I find the volume of this irregular object? Well, we use something called the water displacement method, and you've probably all done this before, but here's how it works. So I would take a graduated cylinder and put some water in it. So let's say I put, 30 milliliters of water. And then to that same graduated cylinder, I'm going to add my rock. So the rock will sink to the bottom, of course, and the water level will rise. Okay, so let's say the water level rose, and now it reads 59 milliliters. Okay, well, the difference in those two volumes has to be due to the volume of the rock. So the volume of the rock in this case would be 59 minus 30 milliliters, which is of course going to give me 29 milliliters. Okay, because my graduated cylinder is measuring in milliliters. Now I'm not worried about my number here, but my unit would be the milliliter. So the second acceptable unit for density is gram per milliliter. Okay, now they kind of look similar. This one over here is gram per cubic centimeter, and this one gram per milliliter. So it's just the denominator that has a different unit. But this brings us to kind of an important point, which is the fact that the milliliter is actually equal to the cubic centimeter. This is a conversion factor that's actually a 1-to-1 situation. So technically speaking, the unit of gram per milliliter is actually the same as the unit of gram per cubic centimeter. Okay, so this is an important point right here, that the milliliter is equal to the cubic centimeter. So you might want to write that down, box it, and put a star next to it. It's going to become a conversion factor in chemistry. Okay, so those are the two most common units of density. Hold on, let me scroll back up here. Technically speaking, though, because density, what I want you to know is that they don't have to be the only two units. They're the most common, okay? But because density is a ratio of mass to volume, then density could actually be expressed as long as it's any mass unit over any volume unit. So, for example, technically density could have a unit of kilogram per liter. And why would that be okay? Well, because kilogram is a unit for mass and liter is a unit for volume. Okay, so technically speaking, density could be measured in a unit of kilogram per liter. We don't see that very often, but it could be. Okay, so variations on the density formula. Well, we have density equals mass divided by volume. So we would use that formula if we were looking for density and I had my mass and my volume. But what if we were looking for mass? So all of a sudden, this becomes an algebraic discussion. So if I want to calculate mass, I have to isolate mass all by itself, which means I would need to get rid of volume. So I would multiply both sides by volume, which would leave me with mass is equal to volume times density. So I'm just going to flip around how it was written. So this is the second variation of the density formula. And I would use this formula, m equals v times d, if I were looking for mass. From there, what if I was looking for volume? Well, to get volume by itself, I would need to divide both sides by density. And so the third variation of my density formula is that volume is equal to mass divided by density. Now, there's no reason to memorize these. It's just simple algebraic rearrangement that can lead you to those three density formulas. However, we can refer back to them, but it is important that you know how to manipulate those equations. Okay, so let's do some practice, and let's keep sig figs in mind just to make this a little bit more difficult of a lesson, and of course to keep track of our units. So, number one, 100 grams of a liquid completely fills a 200 milliliter bottle. What's the liquid's density? So I'm looking for density. I need to know mass, and I need to know volume. Well, my 100 grams is my mass. My volume is 200 milliliters. And I hope we don't need a calculator for this because 100 divided by 200 is a half. And my unit would be grams per milliliter. Let's talk about sig figs for just a minute. We're dividing, so we're looking at smallest number of sig figs. The number 100 has one sig fig, and so does the number 200. So 1 sig fig should be in my answer, and 0.5 matches that perfectly. Number 2, a solution has a density of 1.5 grams per milliliter. How many grams are needed to obtain 10 milliliters of solution? How many grams? So I'm looking for grams, which means I want to know mass. Okay, so we can scroll back up here and find the mass formula. However, I would prefer that we just derive it so that we can improve our algebra skills. So I'm looking for m, multiply both sides by v, and I get m equals v times d. So v for volume, my volume is 10 milliliters. My density was 1.50. Again, hopefully you don't need a calculator for this. 1.50 times 10 is just 15. Look what happens to my units here. Milliliters cancels. I'm left with grams That makes sense because grams is a unit for mass, which is what I was looking for. However, let's talk about sig figs. I'm multiplying, so smallest number of sig figs. 10.0 has 3. 1.50 has 3, which means my final answer needs to have 3. So I need to add a 0.0 to my final answer. So final answer, 15.0 grams. Number 3, if a block of copper measures 2 centimeters by 4 centimeters by 5 centimeters and weighs 356 grams, what is its density? So looking for density, I need a mass and I need a volume. They gave me a mass, 356 grams. However, they did not give me a volume, but that's okay, because what they essentially gave me was a length and a width and a height. So I can find the volume. So 2 times 4 is 8, times 5 is 40. However, let's keep sig figs in mind. 3 sig figs, 3, and 3 means my volume should be 40.0 cubic centimeters. No units cancel, leaving me with grams per cubic centimeter, and that makes sense because this is a density. This time, I would suspect that we need a calculator, and I get 8.9 as my density. But again, let's talk sig figs. 356 has 3, 40.0 has 3, so my final density needs to have 3 sig figs, so it should be 8.90 grams per cubic centimeter. Number 4, the density of mercury is 13.6 grams per milliliter. What's the mass of 8.2 milliliters of mercury? So looking for mass, I'm going to derive my formula again. I need to get M by itself, multiply both sides by V. So mass equals volume times density. So the volume is 8.20 milliliters. And the density they gave me up in the first sentence was 13.6 grams per milliliter. My milliliters should cancel, right? 1 in the numerator, 1 in the denominator, leaving me with a unit of grams. I have 3 sig figs, 3 sig figs, so whatever number this comes out to be, I want to round it to 3 sig figs. My calculator tells me it's 111.52. That's 5 sig figs. I'm interested in the first 3, but that 5 will round it up. So this should be reported as 112 grams. Part B, what volume would 120 grams of mercury occupy? So I just had this formula that I was working with. I'm looking for my volume, so divide both sides by D. So V equals M over D. So mass was 120, that has 2 sig figs. I need my density, and just don't forget that this is a continuation of number 4, so my density was given up here. 13.6 grams per milliliter. My grams cancel, leaving me with milliliters, which again makes perfect sense because milliliters are a unit for volume. So 120 with 2 sig figs divided by 13.6 with 3 sig figs gives me a calculator answer of 8.8235 milliliters. But according to sig fig rules, I can only have 2 because I'm limited by the 120. So 8.8, the 2 does not round up, so I should report this answer as 8.8 milliliters. Of course, I'm attaching my unit. All right, number 5. A piece of silver has a mass of 2,800 grams and occupies a volume of 266 centimeters cubed. Calculate its density. So this one's pretty straightforward. Mass, 2,800 grams. Volume of 266 centimeters cubed. Let's keep sig figs in mind. 2,800 has 2 sig figs. 266 has 3 sig figs. My answer can only have 2. Calculator gives me an answer of 10.526 and so on and so forth, but I can only keep 2 sig figs. 5 rounds this up, and I would report this density as 11 grams per cubic centimeter. Number 6, a bottle has a capacity of 1.2 liters. If the density of ether, that's just an organic liquid, if the density of ether is 0.74 grams per milliliter, what mass of ether can the bottle hold? So I'm looking for mass, right? Rearrange my equation, multiply both sides by V. Mass equals volume times density. Okay, so my volume was 1.2 liters and my density was 0.74 grams per milliliter. There was a hint on your paper, and if you look very closely, you'll see that our units don't cancel. I have liters, I have milliliters, and I have grams. Excuse me. So I can't continue this problem if I have both milliliters and liters. I have to do a conversion. And it's probably the easiest thing to do to convert my 1.2 liters into milliliters. So remember, draw your crossbar, liters on the bottom so they cancel. There are 1,000 milliliters in 1 liter. 1.2 times 1,000 is 1,200 milliliters. And now I'm going to go back in and get rid of this and substitute in my 1,200 milliliters, because now look what happens. Milliliters and milliliters cancel. And now I can perform this calculation. 1,200 times 0.74 gives me 888 grams. But both of these numbers that I'm working with have only 2 sig figs. So I'm interested in keeping these. The 8 rounds the 8 up. So 890. Make sure you put that last 0 and don't just report it as 89. Remember, 89 and 890 would be 2 very different numbers. And the last one we're going to do in this video says peanut oil has a density of 0.92 grams per milliliter. If a recipe calls for a 1/4 cup of peanut oil, what mass of peanut oil is required? And they tell you that there are 237 milliliters in a cup. So I'm looking for mass. So I know I'm going to have to use my density formula. Multiply by V, right? So I know mass is going to be volume times density. Okay. So, but the question here becomes, what volume do I use? Well, they gave me a 1/4 cup, but if I put a 1/4 cup in here, my units aren't going to cancel with my density units. So let's just leave that blank for a little bit. We'll add in my density. Right? And think about this. To cancel this milliliter, I'm going to need milliliters for my volume. So that means I need to convert my 1/4 cup into milliliters. So we'll jump down to the bottom. We'll say a 1/4 cup, which of course is 0.25. And my problem was nice enough to give me this conversion factor that in 1 cup there are 237 milliliters. Sorry, I lost my train of thought. So I get this as, my calculator tells me that the answer would be 59.25. Now that's too many sig figs right now, but I'm going to wait to round it off because I'm going to then use this answer up here. And we'll talk about why we do that in an in-person discussion, okay? And I'll round my final answer off. So I'm going to cross out my milliliters. Grams are going to be my answer, and I'm going to go ahead and do this math. And here's where I'm going to round to those 2 sig figs that were given to me in my problem. So my answer comes out as 54.51, and I'm only interested in keeping 2 sig figs. The 5 should round the 4 up, so I should report this answer as 55 grams. So that was a lecture on density, the units for density,